I think we're going to go ahead and get started. So hopefully you came here to learn about functional programming, or more specifically, how to introduce it at work. I'm going to ask a silly question. How many people currently use functional languages at work? Oh, wow, quite a few people. How many people would like to or would like to use more of it at work? Almost everybody. Awesome. So my name is Robert Kluin. I've held a number of different positions at technology companies, ranging from engineer to executive positions. I've been team lead and a whole range of things in between. And through all those different roles, I've had the opportunity to try and introduce different types of technology, different languages, different architectural patterns. And I've started to realize now, as a consultant helping companies implement kind of DevOps, that it's really not as much about the things that we think it's about. And that's what this talk is going to do, is walk through some of the experiences that I have had and how hopefully you can leverage some of those experiences to introduce functional technologies at work. So let's start by talking about some of the benefits of functional programming. Quite a few people raised their hands and said that you currently use functional languages at work. Does everybody dabble on the side, at least, with the functional language? Most of the people. So how about a couple people tell me your favorite thing about a functional language?
Immutable data.
Immutable data, it's a huge one. Yes. Yep, pick up the function, use it anywhere, so the kind of good generics, things like that. And one more thing. Who wants to speak up? Somebody. Yes?
I like how they model domains.
How you can model a domain more accurately. Okay, cool. So this was a big thing, right? Immutability plays into being able to reason about the code, even some of the generic data structures, and more accurately modeling our domain so that the code matches. The other big thing is, from all of that, we get fewer surprises. I just was working on a project with a really large C++ code base that runs in a distributed environment. And one of the fun things to do was try to debug what was going wrong. We often had to run the code base to understand where especially mutations were happening. I spent weeks and weeks of nights debugging, trying to understand where data was getting mutated in the system. It makes it hard, and functional helps us address some of those things. And that leads ultimately, hopefully, to a decrease in defects in production environments. And maybe even reduce development time and effort, although this is kind of a trade-off in some ways when you talk about it, because it takes more upfront design time. In exchange, though, we save it many times more in the back end, debugging production problems. So basically, it's better in every way, right? I assume everybody agrees with that. That's why you're here. And, well, oops, I got ahead of myself. That's why you're here. So if that's the case, we should be able to just go enumerate that list, and we can all just bail out and go get a beer. But that is not quite how it actually works, right? Just going through the technical benefits, it's not sufficient to actually get buy-in and widespread adoption. In this case, we're actually dealing with human systems, which are wildly more different and difficult than computer systems. So I want to give a little bit of background story. Most of these things came from events at one of my former employers. And it's kind of interesting. And there's a lot of context here that's probably a little different than some of your employers, but a lot of the lessons still translate pretty directly. We were extremely friendly to new technologies. Our CTO basically encouraged always pushing the limits and never doing anything that was kind of standard or safe. It was always try to be aggressive, which, given the space we were in, that's a pretty rare thing, especially with the kind of clientele we had. It was in financial reporting, heavily regulated stuff. So this kind of sets some context on why we got to experiment so much and start to learn how to introduce new things effectively. Basically, the rule was anything that could possibly be better, we were willing to roll the dice and give it a shot. And I don't mean recklessly necessarily, but it was open to experimentation. This included even things like beta technologies, which I'll talk about a couple examples down. It was really a piece of who we were as a company, was to always try to push the limits, try new things, don't just do what had been done. And that kind of leads us to one of our first forays, intentional forays, I should say, into functional. How many people use Scala or would like to? It's a handful of people. I'm going to give you a heads up. This is not going to be a happy ending for Scala. But we learned a lot of things, and hopefully it can help you. So some context on the particular project we decided to try this on. It actually was a case where immutable data was a perfect fit. And also Scala has something called akka, which is a way to do some distributed systems. Had a number of things about the language itself that really is a very natural fit for this particular product we were working on. There were two other key things you should be aware of. It was a very critical project to the company. The kind of thing that weekly updates to executive management were given, that type of critical to the company. And we had a pretty tight target timeline. In terms of the team, it was a newly formed team. So everybody had been at the company for years, but it was their first time actually working together as a team. There were two very, very senior engineers, probably some of the smartest engineers I've ever worked with. And then it was a set of less experienced engineers. Almost the entire team had good familiarity at the basic level with FP in general, conceptually, and none of us had experience with productionized Scala. So we had basically a debate. What functional language should we use? We had one very, very vocal supporter of Scala, and he won out. He made excellent arguments, got buy-in. Everybody throughout the company was excited, and all eyes were kind of on this to see how it went. Most of the team was honestly a little bit indifferent about Scala in particular, but they were excited about the idea of FP. We had little practical experience with Scala in production, but it's okay. It had never been a problem for us before introducing any new technology. The Scala fan just went crazy off the Scala deep end. Which anyone who has worked in Scala code bases is probably starting to have some mental images of what that may have looked like. The people familiar with FP, they just wrote normal functional code. And all the junior engineers just wrote Java, right? I took a picture of some people working on the code base. That's what it turned into, is just a mess of totally different coding styles and yeah, I mean, it pretty much went how you went. Everyone was just doing their own thing. That lack of consistency wound up with even the Scala promoter. I remember sitting with him one day talking, and at that point, my role was head of architecture. And so I was asking, how's it going? What's going on with Scala? Because I hear mixed things. And he's like, it's awesome, it's amazing. Well, except for the fact, every time I open up another file or even third-party libraries, it's like I have to learn the language they're using. I can't just pick up a file and go read it. And so that was kind of a key thing for us. The other thing I heard a lot about was something called SBT. How many people are familiar with SBT? It's awesome, right? I've heard nothing but positives, except no one seemed to like it. It's apparently extremely complicated and slow. And this was probably 4 years ago, roughly, so I'm sure it's in a totally better spot. But Scala build tool. So it's their I don't even know what the analog would be, but their build system. And despite being JVM-based, it didn't fit into our ecosystem that the rest of our systems ran in. Didn't fit into our build systems. No aspect of it actually matched very well with what we were doing. And it ended in a lot of pain and disagreement, which I also took a picture of. So a couple takeaways that we learned from this. One of the things that we like to do is retro on experiences. And one of the things that we learned was that Scala kind of got the blame, but it wasn't Scala. Is it actually an issue with us and Scala? Which is Scala people may be getting amused, right? When I Googled how do you do concatenation in Scala, I got a Stack Overflow page with like 500 answers, so I just grabbed 2 of them. So the big thing was it was way too flexible for the level of experience that we had with the language, for the size of a company. By this point, we had hundreds of engineers, and it didn't actually fit the corporate culture in terms of how we proceeded. We weren't a mandate standards type of company. It was very much a do the best thing at the time type of company, which was one of the takeaways that we wound up with. We should have just taken Twitter's Scala guide and mandated everybody writes code this way, as an aside. We picked a terrible project in hindsight. We thought this was going to be a huge asset, and instead we made a hidden mistake. Almost nothing is strictly better than everything else, right? Everything has pros and cons and trade-offs, and we thought we had actually done a careful analysis, and we didn't intentionally ignore these costs. We thought things like the flexibility of being able to write Java was going to help. We thought the JVM was going to be a massive asset to us because we already had Java code, we already had Java package repositories, build systems, et cetera. And this point I keep coming back to is a key thing. We thought this was going to help, that flexibility. Instead, we misread the signs and we kind of flip-flopped all the things we thought were going to be assets were liabilities and vice versa. So a little more information on our culture, because it can probably be helpful. We had like multi-million line Python code bases. And how many people have done Python or do Python? Almost everybody in the room. Python has this notion of Pythonic. You can, like, I could be right here and see someone in the back screen and fuzzy my eyes, and you can tell if it's Pythonic, right? If it's just obvious. There's something about it. It's just almost trivial to identify, and there's usually one obvious way to do things. It's like a Python mantra that there's one obvious right way. This notion, this Pythonic mindset was very, very much ingrained into the culture, into our development culture. So why did we start getting interested in FP? We had a lot of experience with Python, tons of good Python engineers. Well, partially because we were writing distributed systems. And within some teams, we started to realize that this object-oriented practices, oh no, it didn't play. That was a recording of us debugging some stuff, right? Basically, it's like, you have made your mistake. Many, many, many mistakes. That was how we felt. Every time we dug in, it was just layers of mistakes and misunderstandings and inheritance. It's so hard to debug these types of things at scale. So we started manually, or naturally, writing functional code. Our Python just started morphing to where objects were really treated as immutable data structures. And even with that, we could wind up losing just monumental amounts of time debugging some of these types of issues in distributed systems. These things could run on clusters of tens of thousands of nodes at some points, which makes it really hard to figure out what's going on. But we had some real problems to solve, and we really wanted to find a better solution for some of these issues, which leads us to another language. How many people have used Go? So you're all interested in functional programming, and almost everybody raised their hand about Go. Go probably has the most advanced type system of any language on the market, right? If you consider copy-paste a type system. So we introduced Golang almost by mistake. It actually happened for a prototype that I slapped together quickly, and I showed it to everybody. I was like, wow, look at this performance, and we have at least some kind of like static typing, and it's awesome, and this prototype just totally ran away from us. Like literally, I was on an airplane and I landed, and it just was rippling throughout. Suddenly, everybody was stopping what they were doing, and the emergency rewrite to Go was underway. which I think maybe happened because it was new, it was exciting, it was very, very premature, because part of what happened then is our shipping rate just boom, plummeted out because we were in this emergency rewrite to go phase. We did eventually start shipping stuff again, but the introduction of the language was a success, which we kind of looked at and said, why did this work when some other things had fallen flat? Well, one of the things is that lack of flexibility helped. That has built-in guardrails. That kind of crazy opinionated language or tool set, it helps. Things like enforcing coding style. In Python, it's PEP 8. It's easy. You just boom, PEP 8, every PR, PEP 8. Go just does that. So those types of things help a tremendous amount. And it basically gave us that Pythonic feel that we needed. And again, going back to the type system, it's kind of a simplistic, limited type system, although the new generics work really well, right? That was a joke, sorry. You guys, I saw the excitement. Everyone was like, wait, did I miss an announcement? No, you didn't. So the big thing was it actually fit our culture, or it worked within our culture, which I kind of want to lead with another observation. As an aside, we should have shipped something first, just one thing, end to end through the stack would have been wildly helpful for us. That would have reduced risk, and it actually would have ultimately probably accelerated the adoption of the language. Instead, it was just crazy contentious of trying to catch up, because we really were redoing so many systems without the infrastructure and build tooling in place to properly address it. And it strained a lot of parts of our organization. The biggest thing, though, is this was a lot of risk. What if we realized that we didn't like Go or some other item came along? And this, going back to my comment on beta, if I remember right, this was either pre-1.0 or maybe around 1.0. So we were willing to go all in on things when they fit. But again, we learned from this mistake, and we started adapting it, which leads us to Elm. How many people have used Elm? Elm is actually a legitimately awesome functional language because of pretty much all of the reasons we've been talking about. It was pushed by management, which was me. The big thing, though, is it's an opinionated language. It makes pretty clear on how to do things. And it strips away some of the complexity that you get in other more mature functional languages. The tooling is legitimately spectacular. Its compiler, it's not quite like at a dependent type system type level, but the compiler will just walk you through creating your program if you sketch it out. It's pretty spectacular. We shipped a whole new product, internal product, in about a month, top to bottom. With our other tool stacks, that was estimated at about 6 months of work. And a new language to us, we actually cranked out the product we were wanting in about a month. So there were a few bugs that we'd been working on where we had started that just totally disappeared because we could actually reason about the code and work our way through. And it sounds like an exaggeration, but the defect rate actually bottomed out on this thing. It just let them start focus on cranking out the code. And in the middle of all this, I'm trying to remember which Elm version it was, but there was an architectural change, maybe from the mailbox pattern to the message or something like that. It was a very significant refactoring of the code, and we took that opportunity to just restructure the code base, and that was done in a ridiculously short amount of time, totally safely. I think it was a week or maybe 2 weeks to just completely restructure this application with no ramification, negative consequences. It was a massive, massive value gain to the company, but it was not a critical path project. This was something I had sold to our executives as being a productivity booster for our engineers, but it was something that didn't exist. So it wasn't a critical path, and it wasn't going to directly contribute to revenue. So that was a big thing. That's one of the items we had taken away from prior experiences. Don't trial something like this on a critical path item. And because it was isolated as internal, we didn't have the same requirements as some of the other tools. It wasn't going to be shipped to production, customer-facing production. So we could take a lot more liberties with how we worked and what we did. So a couple takeaways. It fit the culture, just like Go. Very opinionated, strong tooling, and it fit. It let us run with it. Because it was an ancillary project, it was much, much lower risk to the company to try this. And the value was almost immediately proven. Within a few weeks, we knew whether we were going to continue investment or pull back and go keep doing what we were doing. Having a management champion was useful, and I'll explain why in just a moment. It's getting replaced now, and part of that is because some of the promoters have moved on to other companies. That promotion and evangelism was critical, but that's part of where having me championing this for management helped, because I could provide some air cover and let it expand. Unfortunately, once I left and some of the other team looked at it, they were afraid it was going to be changed. And so they moved on, and it did. Which there's one other thing I want to mention, which is a clever way to actually do this and start a conversation. So we had an engineer. I actually hired him when I interviewed him, and he mentioned, I mess with Haskell for fun on the side. And we wound up having a really good conversation. I was like, okay. And then 3 years later, all of a sudden, I learned he had snuck in Haskell in an API specification. So he was actually using this to test and build an API, an interaction model. And he documented all of the expected behaviors of this system. This is it's the core of what the company does, like literally the most core item that it does. He didn't use it in the production code. He used it to document this out. And the brilliant thing about it was it made it possible for us to start experimenting with these APIs and these interaction models. And it gave us good API docs. And the biggest thing, though, is it got a much larger group in the company starting to talk about functional, because the API spec was so readable, is amazing. And then that sparked one of the groups who was building that actual system to go build this thing in Clojure, which this is still happening. It's a massive success. And part of it is because they were able to take that Haskell spec and then go implement this thing in Clojure and rapidly solve the business problem. So no one was talking about the tech. They were just talking about, hey, we're making progress on this initiative. The immutable data model is a massive, massive critical aspect of this system. It fits very, very well. They also helped. I, at this point, was managing the infrastructure teams who owned like build systems, things like that. And they approached us and offered to try to help work with us to fit it into the ecosystem a little bit better, fit it into the build systems. One kind of caveat, though, immutability is completely unnatural in other languages, and it makes very foreign-feeling models, which is not good, because then you have other engineering groups complaining about why is this API not feel correct. And so one of the things they decided to do to keep it from being a discussion on the language they had chosen to use, they started providing native-feeling client libraries and working very diligently to make sure that they didn't adversely impact other engineering teams. So a few takeaways from this. The team just purely focused on providing value. When discussions of their language choice came up, they just redirected away and focused on the value that they were providing. They've done a reasonably good job of hitting deadlines, having a very, very low defect rate. Part of that is because they've put in careful upfront design time, but also because they're following some nice functional engineering principles. They worked with the infrastructure and ops groups, which is a very, very key aspect of making it easy. Because if you alienate the teams maintaining those systems, things get dicey much quicker. They actively and aggressively tried to make sure the conversation is not about the language. They don't want to make it as if though they're pushing this as a, hey, we're changing to this language and everyone else needs to adapt. So they make sure that they're not intruding on others. So a few key takeaways from all this. kind of went over a set of stories, and hopefully some of the common threads and themes started popping out. Number one is trying to manage the risks. That's really key. And this is how you're going to get a management champion, is being able to answer questions like this. So pick a low-risk area or an ancillary project, or if you're a front-end engineer working in JavaScript, pick something like PureScript. That's a very, very good interop story. And go write a library in it, or propose writing a component in it. You don't have to rewrite everything all at once. If you're on the back end in Java, you can write something in something like Closure, right, and interop. So start proving that value and explain how you're going to manage it. And go slow. Be careful trying to go all in. Even in a small company, that's a high-risk maneuver. But in a big company, there can be a very, very serious amount of concern about it. And prove out the value. Start showing, hey, our defect rate has dropped through the bottom. We're doing really well now, or we're going quicker, or whatever that value prop is that you're going for. And the biggest thing is try to learn first. This was one of the items that bit us hard on Scala. Had we prototyped with that first, we would have realized that flexibility and inconsistency was going to circle back and hurt us. So try to learn and be able to answer questions when someone's asking. And the other thing is now, even the C++ stuff I was doing, they've started to introduce a lot of functional concepts into the language. So just start using functional patterns within the languages you're already working in. And that'll help get buy-in, because you can explain what you're proposing in terms of a language your coworkers are already familiar with. This is probably one of the best things to do, and it was how the teams I worked on we started being able to introduce functional, because we were already doing these patterns, trying to get a handle on understanding the code base and reducing defects. One other kind of little aside for anyone who's involved in hiring or is a hiring manager, you really have to plan for hiring. One of the things that caught us a little bit off guard with Scala was that the office that was doing that, we really wanted that entire team to be co-located together. And as it turns out, this is an office in Montana. We could not find experienced Scala people that we could hire there. And this proved to be a very big challenge and pretty negatively impactful. Conversely, the group that had started doing Elm was based in Boulder. And I am involved in the functional community a little bit there. And I knew we could hire people because I constantly had people coming and saying, hey, would you guys do functional languages? I will take a pay cut to come work for you. It's like a crazy thing. So make sure you account for that and be able to explain that. That's an important risk management thing, which was one of the questions I would ask. Anytime someone came to me proposing a new language or a new tech of any kind, I'd say, I want to know, how are we going to support this? Because if you introduce this thing and in 6 months leave, or a year leave, how am I going to support this? So that's a very critical item that you're probably going to want to talk through, which also feeds into, like Golang for us was a bit disruptive, not good disruption, but bad disruption. You need to demonstrate that it's not going to totally trash the ecosystem. Right? Is this going to be a totally different distributed computing model? Do we have to retool all the build systems, package management? What's going to be the burden on the company to do this stuff? Which gets into that. Just offer to help. Usually these people are snowed under anyway, so offer to give them a little bit of help and see if you can get some support out of them. If you can, by having some strategies to talk through around some of that risk management, try to actually get somebody in management who will go to bat and push to help do that. One of the big things, the language itself doesn't matter, or any tech, right? That's not how you're probably going to sell whatever you're proposing to do. It's not the language. We actually had tons of attempts to introduce various favorite languages, Ruby and other things. And those basically always met with failure, because if you just go and say, I want to use this thing because it's my favorite thing in the world, what value does that give to your peers and coworkers and to the project you're doing? It's kind of the wrong thing to focus on, but it's easy to focus on. I like doing that myself. It just doesn't work. The biggest item, your culture is key, right? I've probably said the word culture like 500 times in the last 25 minutes. So pick solutions that actually fit the culture and the feel of the dev environment. Look for, actually this is a big item. You can affect change in the company via introducing new technologies and new languages. This was kind of an interesting thing that we started seeing on some of the teams that actually adopted functional languages. It actually started changing that culture and the connected groups cultures. So it's kind of an interesting thing that I really want to point out. It goes both ways. You have to find something that's going to be able to fit into the culture, but then by getting that adoption, you can start to change and impact the company's culture. It's very much like DevOps, right? It's all about the culture. There's tooling aspects, certainly, but it's all about culture. And as you get your culture to embrace that, it suddenly just radically and rapidly alters the company's culture. And the biggest thing, if you actually want to make pretty much any change, but get a functional language in, you have to become a promoter. You have to just constantly go around selling this idea, educate and evangelize this idea. You have to be able to help get a bigger and bigger group buying in, supporting it, and make them really believe that they're getting some benefits and get them excited about it. That's kind of the biggest thing, and it's often unintuitive for engineers. I know it took me quite a while to realize that that is how I affected change, was promoting and evangelizing. So some groups that I've worked with, we've introduced things like unit tests and CI/CD systems, and in every single case, it was about promotion and evangelizing these ideas. Because if it's foreign and a different way to work, it has a hurdle to get started and change. And with that, I'll take questions if there are any.
So we do a lot of JavaScript at my company, which is like a great language for like using functional paradigms without having to do like totally functional language. But I've been running into some of the issues where like the flexibility of JavaScript is becoming a problem, where it's really easy for people when they're not sure how to do something functionally to just like drop back down to an imperative paradigm. And I was wondering if you had any suggestions for like how to sort of like mitigate that.
Yeah, that is basically the exact issue we bumped into with Scala. It's that kind of easy path. I'm not sure if I have a good technical solution. It really comes back to just education and evangelism and trying to get a team really, or some kind of group really bought in. One of the ways that we started actually getting buy-in to make some of the changes and get the adoption we did was because the team following these practices. So the big thing was getting a core group following that had ownership of an area. And the defect rates in the code we were working on were just completely night and day different. And so that prompted a bigger discussion on why is that team, what is so unique and different about that team's code or how they work. It was how we introduced unit tests. It's how we introduced code reviews. Is a bunch of practices like that were all introduced because we had teams following those things, and it is a very stark difference, which helped us sell it and these things, right? Evangelize, and then education. To get unit tests there, it took probably every single week kind of a lunch and learn type session, and then the big proponents of it actually just sitting with teams and helping teach them and educate them, which was a big thing.
Other questions?
Thank you. So you said that once the team started using a functional language, their culture changed. Can you talk about how it changed the culture?
it starts to shift a little bit how they approached developing the system. And it kind of comes back a little bit to, it's really just in terms of how much risk are you taking when you ship. It starts to alter that type of perception. And it actually is very hard to articulate how it changes anyone who's really worked in significant ways with functional languages. It starts to adjust how you think about programming and approach it. So as an example, the C++ code base I was in, when I redid it, it probably looks very functional to a lot of people. But then when we started doing code reviews on that with some extremely experienced C++ people, I thought they were going to rip me apart. And instead they looked at it, and I believe the exact response was, "This looks pretty damn good." I was like, wow, I haven't written C++ in 15 years. I'm going to take that as a win. But it starts to change. How do we think about structuring code? Small, little functions, right? I mean, they're just good programming practices, but it starts to adjust that culture of let's just approach problems. Even in imperative code, we can apply those functional kind of cultural patterns.
Yeah.
So that's kind of what I'm thinking of with that. Guessing we have maybe one more question.
I'm not sure if you can speak to this at all, but you mentioned that the Elm project that is being changed over to something else. Is there a specific reason why that you know of? Or it seems like if it's got a low defect rate.
Yes, that has more to do with kind of politics. So that was a thing that the company had went in a different direction for front-end languages. And that is not, it wasn't a popular decision with the people making those decisions. So that's kind of where that comes from. Mostly though, the promoters, they kind of moved on. And so there wasn't someone who wanted to vigorously and passionately defend that, which makes sense. If it's not your kind of thing to support.
We have time for one more. This gentleman hasn't had a chance yet.
So where in Montana are they doing functional programming? As someone from Montana.
It's an office in Bozeman. And the company is hiring, and it is a very good company to work for. The guy in the back, middle row, in the orange shirt, you can talk to him. He's got the we're hiring thing.
Oh, sure. Something I was curious about, you mentioned that, said, hey, here's some Go, I wrote a prototype. By the time you landed, everyone was super into it. That one of the positive things, right, is that Go has that similar, that has that Pythonic feel. But then you ran into trouble. Was there something that Go, was it just because of Go's simple type system? Or like what was the reason to start deviating away from Go if it fit so well with what you needed?
Yeah, so that's a very, very good question. So really the challenges with Go were not because of Go. The initial challenges were because we did, in Go, right? Who's dealt with package management in Go? I'm pretty sure there are still like 6 or 7 competing ideals for how to solve it. And due to the nature of the types of systems and the data we were dealing with, just pulling random crap off of GitHub, the InfoSec people would not be keen on that. So we had to solve these problems, and we were early enough that I think after 6 months or a year, something like Go, I think it was GoDeps or one of the very early solutions came out. But we were trying to solve this stuff very early. And just retooling build systems. We are set up to build Python and Java and some C# and some things like that. but Go support had to be added. And when you pull in like package management challenges, it just kind of compounded. So that was the upfront pain of the language. And then what started happening is initially coming out of Python, it was like, oh wow, a type system. I can call something an int, and the computer makes sure that I'm not like passing a map or something in as an int, which in Python is easy to solve. You just write like 10x lines of unit test code per line of actual valuable code. And I shouldn't imply that unit tests are not valuable, but you get the idea. So that was like a huge win. But then after copying and pasting the sort function that you had to custom implement for the 27th time, that's where people start saying, hey, I don't know if this is better because now I have 17 copies of the exact same code that we're maintaining. Maybe generics. If you're going to have a type system, maybe that's a thing that would be nice. Which I don't know if anyone on the internet has proposed that, but maybe we should ask about it.
One last one. So you bring up the generics in Go, but Elm is missing the type classes that are in Haskell, and so you do copy and paste.
Yep.
At least you feel that.
So that's a good point. But type classes are like a nicety, right? You can kind of work around it, and they would reduce it. But yeah, it's a very, very good point. It's where Rust's traits are super cool.
All right. Thank you so much.
All right. Thank you all.